So this talk comes with chocolate biscuits. Yeah, no sugar cubes. This isn't the dropping acid talk, so there's no little bits of paper or sugar cubes. They are gluten and dairy free. And the way you get a cookie or a Tim Tammy-like thing is you either ask something really good or like point out some spelling error that I didn't find or somehow make me laugh or, you know, along those lines. They're a little bit melted, so they're going to be awesome. Cool. We'll have a minute of non-musical interlude and then we'll start.
Interpretive dance.
Interpretive dance, yes.
Where's Rusty?
Yeah, I haven't got my I'll explain through interpretive dance shirt on, so no interpretive dance today.
All right, well, we won't wait for any more people. We'll get started. So let me introduce Stuart Smith. Stuart joined Percona in 2011 as Director of Server Development, and he's got a deep background in database internals.
Cool. Thank you. So this talk is otherwise known as how many different awesome features can I fit into one talk slide that makes it sound like it's totally indispensable. And so I've got the longest talk title I probably ever have, which is Multitenancy, Multimaster, Sharding, Scaling, and Analytics with Drizzle, otherwise known as we'll do absolutely everything for you, because that's obviously ideal. And the other great thing about this, of course, is that if you've started to hack on something but you haven't quite finished it, the best thing to do is to decide, I'm going to submit that as a conference talk, because that will force me to finish it by the talk. And then you have a usual thing of, oh shit, LCA's in X amount of weeks, where X is an integer. I better start working my talk. Oh wait, I better fix the code up so it's not an absolute disgrace by the time it gets to the talk. So that was the bit of multi-tenancy stuff. But luckily, like most of it now is going through either merged. You know, this is the good things. Mark is about to merge it now, so it's like in real time awesomeness going on here. And so, you know, it's not all just vaporware except maybe one bit, which is a little bit more resemble yourself. But you know, that's what happens when you have a summer of code student drop out. Damn it. Which is the one I want to go through first? The key use something.
That's still 3 different branches.
Ah, yes. Yes, Jake.
Do you think that's going to be stable, and can I have a cookie?
Do I think it's going to be stable? Can I have a cookie? Yes, you can have a cookie.
Fantastic. No, of course. Table share use table identifier.
No, it's fix create schema for whatever. That's the branch that fixes everything, allegedly. Cool, so let's get started. So I hack on Drizzle. And first, I thought I'd do a quick overview of Drizzle, because what I find is, especially when I go to a bar and meet anyone remotely technical that somehow managed to work with databases, sometimes they haven't heard of what I've been working on. So therefore, I'm at the pub trying to relax, and I'm explaining what I've been doing for the past few years. So back in 2008, I believe it was 2007. Whenever it was, it's all a haze. We did this, which is a fork. We took the now defunct MySQL 6.0 source tree and forked it and decided that we were going to try and fix things. We're going to try and make it so that it would run better in large-scale modern web environments. So in 2010, we finally finished this sort of long process towards, you know, re-engineering, refactoring, and making sort of modular and nice and what you'd expect from a modern C++ code base that wasn't, you know, a C+ kind of some horrid monstrosity, and it said something really nice and modular. We came out with a stable release that we called Drizzle 7. Why? Because 7 is a nice number. It's pretty large. It's larger than some other databases' version numbers, and it's less than others, so we don't want to, you know, be too much full of ourselves. So it's a nice round number, and, you know, Drupal was doing the same thing, and just, you know, 7 is also prime. And obviously that's the best way to pick a version number to start out with, because, you know, 1.0 like never works correctly, right? So we have very much a modular architecture. We want like not just be able to plug things in as needed, but inside the server we want solid pluggable modular interfaces that are sane. We do actually also have pluggable bits, so pretty much every part of the server now can be thought of as a pluggable component. There's a couple of things that are still a bit monolithic, but like can completely rip out and replace them, like the network protocol, replication system, what functions get loaded, what storage engines are run, all these kind of even ways to log, even though you go, why would anyone load anything but syslog? You can always plug that kind of stuff in and do really neat things that way, which also lets us actually design sort of nice APIs between things, which if you've digged into anything, especially in like the storage engine layer of MySQL, yeah, that wasn't in existence. We wanted to make sure the database became infrastructure aware. So we wanted to get rid of this mindset of databases being this great central sacred knowledge of everything and all hail the ultimate database, because those kind of days come from when computers cost millions of dollars and everyone ran SQL queries bashing into a VT100 terminal in their special desk in their special office, and this is how you would do things, because it was all hail the great database and everyone wrote SQL by hand, and small furry creatures from Alpha Centauri were real small furry creatures from Alpha Centauri. So instead what we wanted to do is change our view and say the database server is actually just part of a larger piece of infrastructure. It should not start to dictate things. That is, you should be able to have pluggable authentication. We shouldn't have to duplicate all of your authentication authorization information inside the database. You should be able to actually plug into an existing system. You should be able to plug into existing logging. You should be able to plug into existing analytics systems and maybe replicate to a different type of database that is much better at doing large analytics as well. We wanted to make it infrastructure aware and not dictate your infrastructure. Because in reality, anyone who runs a database server, nobody has a VT100 terminal for every user whacking in SQL queries. You all have it as part of a larger piece of infrastructure for your app. Or am I wrong and you all still give VT100 terminals to everyone? Yeah, well, look at me. I'm the guy with the Apple I clone. So we also wanted to be community developed. We wanted to have a large number of people from different companies and students and volunteers and anyone who had an itch to be able to scratch it. And we wanted this to be a very much more of a level playing field. That means we have a Linux kernel style model of development where you have people doing their thing and you have one person or an approvals process to get things in the tree. We didn't want it to have there are these sacred few committers who can do whatever the hell they want and no one can tell them otherwise. We still wanted to have review and everything, but we wanted to have a community project. We very much succeeded in that. If you actually look at the variety of people and companies that have been contributing to Drizzle and working on Drizzle, it's a very large variety. We're very easy at taking contributions. For example, we focus on the quality of the patch, not if you've signed some sheet of paper. So we wanted to go to, of course, multi-core, because you can't buy a single core tablet anymore, let alone an actual computer to run a database on. And of course that means we care about concurrency. We also wanted to focus towards the web, which means we get to do a few neat things like, say the web is UTF-8. Yay, Unicode snowman for you. Seriously, it's just you think someone would go, huh, but whatever, it's like UTF-8. Who cares about anything but UTF-8?
Shift JIS.
What?
Shift JIS.
The Japanese one, yep. So the Japanese guys were like, well, maybe. So they took the entire contents of the Japanese Wikipedia and compared it in disk size. Turns out, negligible difference. So, solved. We also wanted to enable others. We wanted to be able to enable people to build sort of businesses and applications and everything around it with sort of a modern code base that you could actually quickly say, oh, I wanted to write a function because I wanted to use a new hashing algorithm, or I need to plug into my authentication system. You should be able to go in and use your modern code base that you have in this lovely database server and write what you need very quickly without it being a pain in the ass. This also completely has this wonderful feedback loop of when we make nice clean interfaces, it's really easy to do things ourselves. So when I talk about all these giant features coming out and whatever that you think that's really cool, and then you look at the amount of time it actually makes to make those new things happen once you have a solid base, it's really an amazing short amount of time. So unfortunately, a bunch of the talk is yeah, and then it's really easy because we made the code sensible. So that is a good advice to people out there of don't have insane code. We came from a code base that had sort of very monolithic, interdependent things which were opaque data types are for wusses, APIs are for wusses. You know how the memory layout is for this string of bytes, just poke at it directly. And we didn't want to do that. We wanted to have it easy for someone to jump in and scratch their own itch. And we've definitely seen a lot of that now. Collaboration was a big thing. You know, everything's up on Launchpad, no secret internal trees. You can always get the latest from there. You can even like pull stuff that's like way broken from development trees because it's, you know, upload it to the internet and let everyone else mirror it. We have strong participation from people. We've done summer of code a lot of time, of course, and build businesses, which comes to the one commercial plug, like support and consulting from the company I work for, Pecona, there. Done. We were very big on testing. We love to hammer the database and break it because that makes us joyous and cry at the same time. And so we're probably, the sad state of affairs is that we're probably the most well-tested open source database server. And that's sort of not something to be happy about because the state of the art in like free software database testing is like where Microsoft was in 1998. So, you know, we've got a little bit of catching up to do, but we're pretty good at being able to test it, make sure it doesn't crash, get sort of reliable results back, or at least, you know, everyone agrees that the results are the same, whether they're correct or not, you know, exercise for the reader when you have a 64-way join. So we want to do a few things. Transactional by default, of course, because who here has come into a system that's like running way too big and discovered they're like using my ISM tables and expecting it to have transactions? Yeah, that shit should never happen. I mean, default, easy. We wanted to have that all the way through there, so we wanted to lay in infrastructure, for example, no implicit commits. Who can name an implicit commit inside, just say, a large database server that hasn't hacked on Drizzle? Implicit commit. Do it inside the middle of a transaction. It will commit your previous one and keep going. If you do DDL, it will also kind of silently do that. So, you know, if you do DDL in the middle, it's probably broken. And there are a couple of other weird-ass ones as well. We, of course, wanted to have pluggable logging, and, of course, we had pluggable replication. So pluggable replication opens us up to some really awesome things. If your replication stream out of your database is actually a standard and documented interface, it can start doing interesting things. Like, why would you just use that for replication? You now have a stream of events coming from the database server that describes every insert, update, and delete going on. So if your example is inserting like Apache logs into the database for like further analytics, you get this stream of what's currently happening. So you could have that fed into just say RabbitMQ to have a job that then feeds it back to the browser to live update the cute little window of which countries in the world people are downloading your software from. And you can do this like without doing a whole bunch of extra layer here and just nice stuff processing it out there. And someone did that as a cool demo. It's pretty awesome. Of course, we want to do pluggable auth, PAM being the one that you sort of implement and go, why did we do anything else? But turns out some people don't use PAM. Also, amazingly enough, if anyone was ever to port this to Windows, it makes it much easier to plug in there. We had a big policy of no bad data. That is, we have like a very strict mode by default. Turns out inserting null into a not null column is like a bad thing to store. And like there was, has everyone like gone, wow, it's February 31st today, isn't that great?
Year 000.
Yeah, year 0, turns out year 0 didn't actually exist. Do you know there's a 0th month in the year? No. You know, no bad data. Everyone in the modern web world, right, you're checking stuff like at the front end there. If the database throws an error about you inserting bad data into it, that's probably going to help you. It's not going to be, hey, just accept any old garbage and we'll deal with it later. We also had this cool idea of that the client libraries should be BSD licensed. So one of the issues if you have GPL client libraries, of course, and you want to like run commercial software, then you're, well, who cares anyway? But you know, you have a problem shipping things and distribution and linking with things perhaps aren't GPL or GPL compatible, and then you have a whole bunch of license flow. It turns out license conversations can like drain your soul. And make you want to drink yourself silly with very nice scotch. So instead we wanted to not have that problem or any of those discussions and instead focus on technology and instead just have BSD client libraries and problem solved. So oddly enough, these also connect to MySQL because they speak the MySQL protocol. So the amount of people just using our client libraries to connect to MySQL servers because they're also faster is amazing. So have a look at it for that. So we had a good baseline. So Drizzle 7 was this good baseline. One of the ideas was, okay, we've done a whole bunch of radical changes. We've done a whole bunch of testing on it. Now, where do we go from here? And one of the goals of the Drizzle project was to eventually help solve the problem of how do web apps grow. That is to say, we all know sort of some idea of how to get bigger and how do you go from like really small to really big and how do people scale with this. So one of our goals was to help in this scenario, and of course one of the things you do first is like, right, let's not just hack things into the database but rework it. So Drizzle 7, like the initial release, stable release, was one of our ideas of let's get that, and then let's see what cool stuff we can do. So let's see about what do you do first? Shared hosting. If you're going to write a web app, you might just get an account shared hosting. So you have someone's running a server or VM somewhere that has a database server running on it, and then they do the simple thing, because all it really supports is they give each sort of customer or your web app one username with one password that has rights on everything to one database. So as long as you don't want to use multiple databases, and I'm going to use database and schema interchangeably because it just confuses people otherwise. So you could say one schema, MySQL calls it a database, Drizzle we call it a schema because that makes a bit more sense. So you only have one user password, one schema name, and you can do whatever table stuff you like, and your app can really do anything. And you don't get access to maybe the database server itself, so you can't really do your own backups, or maybe you can do a SQL dump. Everyone else can interfere with each other because all these different users and apps are running on the one machine. So if this database is really big and yours is really small, odds are it's a bit more heavily used. It will force all of your pages and your table to be out of the cache and on disk, and every time you run a query it'll go to disk, and maybe it's a bit busy. Maybe they haven't tuned it at all, or maybe they have, but you still have issues with sharing resources. But for your WordPress blog that isn't widely read, that's fine too. So this is how people start off with things. Very small, very simple to get running. The next step you could be is run your app on a single machine, right? That's pretty easy. Or you could run it inside a VM, right? You just say, start a VM, we're going to have one dedicated database machine that's only for us. And perhaps it shares web and app server as well. But maybe it's in the cloud. So in reality, you're running a VM on a machine that's running a bunch of other VMs that are also running database servers. And in the, what's best named was the Stuart and Selena Comedy Hour yesterday, we discussed the idea of basically, 300 IOPS. Turns out running virtualization doesn't magically give you more IOPS. So if you have, 10 virtual machines running databases on one physical machine that has 300 IOPS, each of them are going to get 30. So, that's not necessarily a great thing there, and you can have all sorts of performance issues there. And usually, at some point, people will go, oh my god, this kind of sucks, unless you turn off durability and then it's really quick. Because, fsync is for people who care about their data.
Go MongoDB.
It's one day where I don't rag Mongo. So the next thing you might do is two separate machines, right? So your app is now using a lot of memory, and it's like a lot of TCP connections and a whole bunch of stuff. So maybe you run an app server and a DB server. Step 3, maybe multiple app servers. Maybe it does a lot of work. And then you need more DB capacity, right? So your database server is using up all its I/O or something. So that's hard. To sort of add another machine. So you buy a bigger one, because what can't be solved by buying more hardware? Which is totally an acceptable thing to do. For certain levels of increasing scale, just buy a new machine. They're so cheap compared to people. People cost money. You sure I don't work for Oracle? Should really work for a hardware company one of these days. Oh wait, I did. They lost all their value and got sold. Read into that what you will. The business cards are valid for 12 hours. No, 12 hours. This is why I don't have business cards anymore. So bigger database machine. There I solved it, right? Just buy big hardware. Just buy big hardware all the time. You've solved the problem, and you can keep doing that for a fair amount of time, right? Because hardware is cheap. And if you scale slowly enough, this does work with Moore's law. So you just have to not sort of exceed that problem.
So just insert the talk. Just buy a fucking SSD already at this point.
Yeah, like at this one point, buy an SSD and like buy many of them, and then buy a Fusion Ion card. Programmers are really expensive if they're good. Yeah. So, or you can do sort of master-slave read-only replication. Pretty much everyone supports read-only replication. So you do, maybe you just want it as failover or something, so you have availability, but usually you'll have some load. So then you go and rewrite your app, because when scaling, you always rewrite your app 15 times, mainly because you didn't see things to first. And then you go, well, maybe I could have like read-write queries going over there with the horrible colored lines, sorry. So move most of the read-only work to query the slave. And this is like probably either asynchronous replication or maybe synchronous or some kind of foo going on there. But asynchronous gets you a lot of win. And then you rewrite everything to use a caching layer, because it turns out that reading still the database is a bit slow. So you rewrite your app again and go to memcache as well. So now you have more logic in there to go whether you're doing a read-write thing that may also need to update memcache, and then you go to a read-only slave, and by this time, you're having a lot of fun. And then if you're really lucky, you get to have multiple read-only slaves. That's, of course, if you're lucky enough to have a workload that scales reads more than writes. If you're very write-heavy, then you're looking at one machine that's still taking all the writes, and you go, oh dear, that's going to be tricky. Yes, the man from Oracle says you can buy stuff from Oracle.
And then the replication's too slow because it's single-threaded.
Oh, yeah. Oh, that's like CPU is infinite, right? Buy a bigger machine. But then you decide, okay, well, I can alleviate things, maybe put all my reporting processes instead of these other machines. I could just do a read-only DB that I only do analytics on, and that alleviates some load. And one day you're going to need more masters, right? As I said, you've got more and more data, or more and more data that's sort of in the current working set, and you're going to need, maybe you've got more write load, you're doing lots of inserts. So what do? Well, one option is, of course, to turn off durability, so you're no longer crash safe. Turns out you're really fast if you never have to write anything to disk, because memory is lots faster than disk. That's completely valid if you hate your data. I advise it. So you're probably going to look at something and you're going to come across this word, multimaster. Think if I could only have multiple masters. If I could only have multiple masters. And it turns out that this has its own set of issues, problems, and the dropping of acid, and not in a good way. And also a whole problems in crash recovery, right? So you update it in one, then one crashes, and then what happens there? Or you start to look at sort of clustering things that then have their own set of scaling issues, because of course, guess what? To not have conflicts going on, you're going to have to do some kind of locking or some kind of resource contention going on there. So you hit your own kind of problems there and your own set of management. And of course, you have a cluster which always works flawlessly. They never have global problems that brings everything down. So one giant one is obviously going to cite, again, own set of problems. So you go for an idea of maybe we could just shard things across machines. And this is especially true if you're going to get to very large data sets. So you can giggle like a schoolboy if you know the other word for that. But sharding is this idea that you then partition your data set up across into different distinct data sets. So you can have the idea of just saying, very simplistic approach. Your app just puts everyone with A to K in one and then L to Z in the other because that's easy and all the names are balanced, or some simplistic approach. And of course, naturally that doesn't work because everyone is named Michael, at least if you're me. Seriously, I once had a phone that only searched through the address book first name. It was horrid. So instead you use some kind of hash and you partition it off, so you do some consistent hashing foo that's going to be awesome, and then you need to reshard at some point because you decided you were going to have 3 shards and now your app's going to actually use more stuff than that. So now you go, oh, how do I split up consistent hashing stuff and pardon?
You used MD5 and somebody decided to make your data set all fall into one shard.
Yeah, someone just hates you and discovers that, oh look, there's the 4 in the hash you're using. I'm just going to fill up one of your database machines and then the next one. So sharding is easy, resharding is hard. And then you have the other problem of, say, now you want to do reportings or analytics or some kind of analysis in your data that previously fit really well into different containers, but I do want to run how many users used the word frog yesterday, and now you can have to do cross-shard queries. So what do you do there?
Roll up into a ball and cry.
Roll into a ball and cry is definitely something that deserves a cookie. Buy good scotch. Yep, that's another one.
Where's sysadmins? We're already prepared for that.
Oh, up the back. This is ridiculous. At this point, the AV people are crying about the camera position. So we have cross-shard queries. So what do we do there? Well, you just have each reporting app query every single shard, because writing joins in the application is exactly why you deployed a database server. Because obviously, of course, since we can't get joins right in the database server all the time and have so many problems getting them right, you're going to implement them perfectly in PHP with people who've just graduated high school. Right? And also, the keg of beer next to the desk is going to just make that code a whole lot better and more reliable. What could possibly go wrong? Exactly. I mean, it's easy. You just load every bit of data into an array inside the server and you sort it that way.
I always had a magnum of red wine when I was doing coding.
Magnum of red wine is a lovely solution to so many database problems. Joins in the application, problem solved, right? So a lot of the times you've actually sharded for various write I/O performance. So what you're actually doing is having a whole bunch of, ops that actually must be synchronous at that specific time. But if you think about for analytics, you probably don't necessarily care if you're up to the absolute latest second of data. So what you can then do is something, you could think of doing something really easily, right? Take all of your shards and just replicate it into one. And you think, why? Oh my God, the amount of data. It may not be that big, because usually what your scaling problem is IOPS on the actual DB masters. And so what you could do, pardon?
Because you're stupid and still buying Rust.
You could still be using spinning Rust, or the fact that there is known failure modes for spinning Rust that people are. And the other thing is there is like capacity, right? Buying huge SSDs is expensive, but buying huge spinning Rust is not. So do all your IOP heavy stuff on SSDs and then just go down into one. And instead of like having every single transaction be disk durable and safe to recovery here, you could just say, as long as I recover to the nearest 10 seconds and you can recover from that and pull everything that you missed, then that's fine. And then just do one giant analytics and reporting stuff there. And this could be, you know, a great way to scale and still get your analytics and sharding and everything there and not have the application implement joins, because that way is the road to hell. Of course, then you have the problem of your database server can only source a replication stream from one machine at a time, because it was written in 2 weeks 12 years ago and hasn't really changed since then.
But the main problem is the replication is the bottleneck with, at least with us. The replication is the bottleneck. Running from 2 shards into 1 is just not going to work for us.
So the big problem here, of course, is for this example, if you can only source from 1 at a time, then you have the big problem of you're only ever going to be running 1 at a time, and odds are you have a lot of data and it's going to suck.
The single-threaded nature of
Yeah, if you're doing single-threaded replication, it's a problem.
Yeah.
If you're doing single-threaded replication, it's a problem. Right. So odds are you can only source from 1 at a time. So you can switch between them all and write some horrible 5,000 lines of bash script that works fine as long as you never have a failure. Because that's always what you find running in production anyway. So by this point in time, and you've just run into the fact that, you know, replication is probably running in 1 thread, and then you kind of have to switch this to analytics, and you've already discovered joins in the application. You've drunk your magnum of wine, you've drunk your keg of beer, and you've drunk your 3 bottles of scotch, and you've got 99 problems, but a solution ain't one. Pop culture reference!
I think you deserve a cookie for that one.
I think I do. I don't know if I can eat it in the middle of the talk. So how do we fix it? Yes, they're vegan and gluten-free.
It's Stuart. What did you
So what do we do here? So we need to fix it. One, how do we fix replication? So for Drizzle, we looked at the MySQL replication system, and we had 2 choices, fix it or replace it. So I had a bit of a clue there. It was originally written in 2 weeks by someone, because when you're a small company, oh my God, you can add replication. 2 weeks later, there's replication, and it's statement-based replication. It turns out that with MVCC, statement replication can never work. By definition, it can never work with concurrency, right? Can never work. So instead what you do is take a whole bunch of extra locks to try and attempt to make it work, then attempt to munge around a whole bunch of non-deterministic functions you have, for example, current timestamp and the like. And then you try and make that work, and then you have a list of exceptions as long as a giraffe's neck. And then it kind of ends up working pretty well, because everyone just learns those giant list of exceptions because they've already deployed it everywhere. So we decided to replace it with something modular and sane. Oh my God, modularity. So we completely ripped it out, and the idea is that we're going to do sort of the equivalent of row-based replication. Let's replicate what actually changed to the rows, not the statements that caused them, which means you can actually rip out a whole bunch of interesting locks from the database server itself. InnoDB auto-inc lock mode is the variable you should look up, then look up the code for it, and once you've stopped crying, yeah, go with it. So, oh my God, modularity. Kernel. The idea is that the kernel of the database server, because we tried to have this idea of you have this small kernel that you can understand as a single human that's only, you know, a couple 100,000 lines, and then everything else is plugins, and all the world is awesome. We wanted to have a simple API. So it has a couple of plugin points where you can get everything that changes. And then you have a plugin that does something with all the changes that's going on. Yeah?
You mentioned your slide had protobufs. Does it actually use protobufs?
Yes, it actually uses protobufs. Write a replicator in 30 lines of Python? Yes.
Actually, I was thinking run your plugin on another host.
Yes.
Yes. You can do,
That's equal.
yes. The first replication applier for Drizzle was 30 lines of Python. As in, you can process your replication and do it to whatever. And so it always says, oh, you can replicate to whatever database. And it's like, all you have to do is write 30 lines of Python. And you know, that's really easy and not what I'm going to do on a plane. Instead, I'm going to take something hard to do. So the plugin does something with it. For example, it could write to a file. Just extract a file that's to the start and end of whatever of everything that's ever changed. It could write to a table. So it turns out that we have a transactional database engine, and our primary cause of contention is fsyncs. And one of the problems for doing a crash-safe master, especially if you keep your replication log in a separate file, is syncing between these two files on the one machine and keeping these in sync. So if you pull the plug, it comes back and everything is happy and dandy instead of horrid. So what you typically do then is two-phase commit instead of in a distributed environment between two files on the one disk on the one machine, which of course does not lead to hugs and puppies, so no one turns that option on because it's too slow and no one has a crash-safe master. But instead, we have a transactional database, and we have changes being applied in a transaction. So why don't we write the replication log in that same transaction to a transactional table? So we did that, and you go, oh my God, you're now writing the data to disk instead of once, you're now writing it 4 times. Turns out, that is a lot faster. Like, a lot. Why? Because you're only doing one fsync. The amount of stuff you can do in a single fsync will boggle your mind. Seriously, turning on a server from once, running a CIFS bench workload, turning on replication in a crash-safe master mode has about a 10% performance impact. It's not 50% or whatever, it's 10%. It's awesome. And that even will work, if you turn like group commit awesomeness on. So, slave, pretty easy. Read protobuf messages from the master in the right order from where you were last up to, and apply them, and you're done. Easy, 30 lines of Python. The default slave stores the state in InnoDB. So if you did like with a relaxed model, instead of like individual transaction committing, you did only maybe up to the last 5 seconds could be safe. Guess what? Automatically, magically works with replicating from different places and applying them and doing IOPS nicely. So you actually avoid the whole idea of single-threaded replication being a bottleneck there. You can avoid a whole bunch of that and delay the problem simply because you're now not having bad IOPS. You then have, because you've got row-based stuff, you can actually do interesting tricks doing parallel stuff. So doing parallel apply is still like a, hey, I think we know how to do that. It's not like existent yet, but just someone needs to start whinging about it and we can start working on it. So you think, where do you store the replication state? Well, I'll store it in a table because I have a transactional data store of where we're up to as part of the transaction of applying it. 1 row per replication source. So doing multi-sourced replication, so from taking from several database shards and replicating into one, doing this without conflict resolution, for example, if you were silly enough to name everything the same table and update the same row in 2 different places, so no conflict resolution, and doing sort of a ring of replication or whatever you want as a tree, was really easy. So part of the benefit of refactoring everything is this is the slave configuration for doing 2 sources of replication. The implementation took like a weekend. It was like, hey, just launch a separate thread to pull things from different places, right? That was easy. You turn it from launching the thread to run the replication to, in a loop for each configuration item, launch a thread, and it all magically works, which is really, really neat. So if you wanted to do sharding now with analytics, you could do really easy. You could just replicate from all the different sources, commit it here, not worry about IOPS, and then you have multi-sourced replication with your, oh my God, you must commit this now layer at the top. Then you have your whole cheap bulk storage there. You can do analytical queries directly to the database, do joins in the database where they deserve, and so simple when you've made the code neat and modular that this was, a weekend project in the end. So if you did a special design schema, of course, instead of giving each shard a different schema name, you give it all the one name, and it could all be in the one database, and your joins would be a bit more sane. So that comes down to just making sort of application design a bit easier. And this is sort of something you probably want to look at, like auto increment, and the like, and this requires a bit more specialist design. One of the next steps is, of course, creating multi-source replication with conflict resolution. So you have 2 conflicting updates, then who wins? The easy way to do that, of course, is maybe have a timestamp and the like, or do you want to run some arbitrary code? Usually this means that you're going to have people think about things, and they probably don't realize all the consequences of it, so good luck with that. And that's still your problem, not mine. So the other thing we wanted to do was, of course, good support for multitenancy. That is, we wanted to have, so currently if you grab a database in the cloud, odds are it's a VM. It's either one of 2 things, right? It's either the one account to one database on a giant shared database server that you kind of hope, or it's a VM running on a machine with a whole bunch of other VMs, each running a database server in them and competing for a limited number of IOPS. So virtualization, just amplifies your problems because, IOPS are eaten for breakfast by database servers. and memory for lunch. And admin of database servers is hard because doing DBA for like one machine is hard enough. Doing it for like 100 machines that are all virtual machines on the one physical machine is kind of like saying, I like to hurt myself.
Please, sir, may I have another?
Yes, that's pretty much it. And we don't want that. Instead, what we want to do is make one database server appear like more than one database server. So what do we do with this? Well, this was harder. This was one of the harder things to do. If you look at some internals that we inherited from MySQL, you can think of this schema.table. This is the namespace, right? You have a database or a schema you connect to, and inside that you have tables. And we wanted to basically add another layer above this. That is to say, every individual user, so each sort of cloud database user could have their own set of schemas, their own set of tables that would be completely separate. It would be impossible to write a SQL query that could query between them. It would be very hard to leak permissions because you don't have your own set of permissions. So as once you got to the point of being able to connect to your own catalog, you would not be able to access somebody else's stuff unless there was some horrid bug inside our database server code that we'd all have to go home and cry. And we'd get the same benefits of running all in one database server because we could all do like group commit goodness, so you wouldn't have to have as many IOPS, and then you could like partition resources based on catalog. So say each user catalog gets like a gigabyte of buffer pool and the like and stuff like that, and an X number of maximum connections and the like, which would be really neat. So we call this catalog. So each cloud user connect to a catalog, maybe by different virtual Ethernet interfaces. So each IP address, you connect to a different catalog. Maybe it is you to some sort of prefix you put in there or something in the protocol. So we have some device to do that. No cross-catalog queries. Excellent. So this is how MySQL internally referred to a table. Question? Yes?
I'm just wondering if you get a cookie for not only answering your phone, but having a conversation.
Probably not a cookie. Anyway. This is how MySQL referred to a database and a table, which is actually suspiciously looks like a Unix file system path. Of course it is. It is a char star. It is just a character string in there. It's actually a directory file prefix. So at various points in time in the code, you may get that as an API with .frm in the end, or IBD, or MYI, or MYD, or something, and a whole bunch of manipulation for that, which is really bad. Except sometimes, of course, you get it this way. Only sometimes on Win32, only sometimes for some calls you get it that way. So don't use that as a key otherwhere in your software, which is a problem that we also hit in ODB. And then there's capitalization dependent on file server options and server options. Go look at the docs. Nobody understands how that works. Seriously, no one's had that much to drink. And then you have encoding of special characters, which also screws you up. Then you have a whole bunch of bits of code inside the server that did stretcher, because how you find out what database is in there is like, well, you go and do stretcher for the slash or maybe the backslash if you screwed it up or not, and then try and sprinkle that everywhere. And then you have some places we had a null in the middle of there to do a key into a hash, and then because, then it's converted back to a slash by doing, finding out where the end of the string is and replacing that and copying it because, opaque data types are for wusses, and this is obviously the right way to do it, and by this time you've gone insane. And of course, char star is, hard, especially if you think, I want to add another gap to the front. How would I possibly do that? Of course, everything would compile all the time. It just mostly would work. So instead, we wanted to do refactoring to the rescue. Let's use an opaque data structure. So we used a whole bunch of identifier classes. So then we let GCC do the work. When we got it wrong, compiler spewed out an error. Brilliantly, we can have C++ tell us that, no, you can't copy that object. It's silly. Pass it by reference. We can also say that, OK, so now you're creating a schema identifier. This means you have to already know which catalog it's in and other such things to force the code to be always correct. And of course, going through and implementing this, you heard this scream a lot in the IRC channel. My eyes, inconsistent API, column, comma, dot, table, slash, backslash, pass, leaking down into InnoDB somewhere in the table. Oh my God, how did this ever work?
Poorly.
Poorly, if ever, and oh my God, the exceptions were insane. So around 2011, we were about done with that. So this is how the steps to have multi-tenancy going. And this was enough to do in a weekend where the majority of the time was spent waiting for the compiler to tell me what to fix next. So we add support to the session object to be able to say you're connected to a catalog. So you're not just connected to a database, you're connected to a catalog. We have a protocol plugin that accepted catalog. So initially we just had console, which is like a standard in, standard out type one. And later I added support for a TCP connector, because it turns out that that's useful and not everyone just types database queries into their console. And then we just needed to properly deal with being connected to another catalog. So we needed to change some internals, like don't shader into something silly, make sure replication works with it sensibly, and make sure everywhere you use catalog you're connected to instead of the default one, because we were halfway there. And that actually only took a weekend to make it work. So the current status for that is it's mostly merged. TCP connections is not quite merged yet because I haven't put the merge proposal in. But it's at the point where you can actually have 2 separate catalogs with both with the database named test and both with table in them named T1 and have completely different contents in them, completely different structure, and it's all nice and isolated and it works. Right? So the only bits missing are have a good way to connect to it via TCP, and I have to fix up the last bit for like data dictionary, so like show tables works. But real application writers know what database tables exist in their database. Jeez. So that's the last bit. So that's like the last thing that's going in really soon now. So it's getting, and the auth plugins will have some slight tweaking, but it's like the large, hard, tricky step is done. The last tricky bit, this was me trying to fix it about every 2 months for the past 8. I finally found the last few bugs, which was lovely. Auto sharding foo is a bit more complex. This is one of the holy grails of things. Many have claimed that use our magic bit of software, your application will automatically be sharded and analytic stuff and cross-shard queries will automatically run. You'll never know. It performs brilliantly. Monkeys will fly out of your ass, exactly. It will be like that awesome. I don't know how that would be awesome, but go with it. And like this is exactly the claims you'll see there. It's, to varying degrees of success, mostly meaning they're lying to you to some degree. So we decided to...
If you're really lucky, they'll know they're lying to you.
Yeah, if you're really lucky, they'll know it. So stop reinventing the wheel. So the basic idea is that you use something called vbuckets, which is basic, like instead of having specific shards to specific machines, create a whole lot more shards than you would need, and then map the shards down to individual machines. And then it's easy, right? You just move an individual one of these blocks to a new machine as you need to load balance across. And you have a whole bunch of funny lookup tables, right? And you go, oh my God, lookup tables going to be huge. No, it's not. It's like a couple of K of memory, and like you have gigabytes. Who cares? And of course, resharding becomes easy because you just point something to something different. And naughty, he says, with probably out his phone on silent. So resharding becomes much more easy because you could have these in a separate schema, and moving a schema from one machine to another is a whole lot easier than, say, trying to repartition the contents in there. And the idea, you'd have an API at the end, which is say, hi, instead of connecting to a database server, I would like to connect to this shard key. Give it a shard key, and it gives you, a connection object back. And then you can say, I want a read-write connection, or I want a read-only replica, and it will give you back an appropriate connection. So this is a real common approach. Memcached does it. Even NDB does it internally to do like online table reorg and the like. And this is, insert hope of having proof of concept working by talk here. So basically there is libvbucket, which you can actually use in existing code. It's not tightly integrated with libdrizzle, and so the last bit of stuff is actually having that tight integration happen. But you can actually do all that proper mapping layer with a manual helping with existing libraries, which is pretty cool. Catalog and replication status, multi-sourced replication is in tree, will be in the next release. The catalog stuff for doing multi-tenancy will at least mostly be in the next release. Whether I say it is stable and you can use it is down to basically how quickly I can finish those last 2 things. And if so, we're going to say, this particular feature is a little bit beta, but all the solid stuff still works, which is pretty neat. The client library stuff, as I said, there is libvbucket, there is libdrizzle. You have to do some little bit of glue yourself currently, so the auto magic isn't already there. That's one of those great things that's another 4-hour project. So of course I did that before LCA. So that's really coming. That's a really short thing to do. And we still have all the other awesome things that makes us useful for web infrastructure, like hating global mutexes and trying to not implement features that screw you on performance. So thank you. There is a Drizzle thing there, and if there's any last-minute questions that I'm over time for, or...
Now we've got a few minutes for questions.
Excellent. Or cookies.
I listened to, on the Floss Weekly, there was an interview with Marty about MariaDB, MariaDB, and
Yep.
he was saying it was wonderful and Drizzle was no good and stuff like that. What one should we go for? I mean, is Marty wrong and you're right and stuff like that? I mean, which ones should we use? If we're going to use a database from Percona, then what should we use? Should we use Drizzle? Should we use MySQL? What?
So
thank you.
Yeah, excellent. So there is MariaDB. So MariaDB is, you would more say it is a distribution of MySQL. And Percona Server, which is what I run at Percona as well, is much more closer upstream. So Percona Server is pretty much MySQL plus 10% that makes it faster, more available, and more ability to monitor what's going on inside it. So we're very much plus 10%. MariaDB decided to make a lot more in-depth changes. So it has a lot of optimizer changes. It has a lot of like new engines and new other things and a lot of changes, which is like, great, I get all these extra features. One problem, since they're still wanting to track upstream and they have a large delta, like for example, they don't have a stable MySQL 5.5 based release out. So if you want all the stuff that's in MySQL 5.5, MariaDB is like, we'll have it soon, and has been for a while. And they're going to have the same problem with 5.6. So MySQL 5.6 is nearing the point where I'm guessing at some point sooner rather than later they will say, here it is stable. Of course, it's Oracle, so they don't publish when they're going to do these things, but you can read between the lines. And so you have more of a delta there. But like Percona Server is meant for entirely a drop-in replacement for MySQL. MariaDB also claims to be entirely a drop-in replacement for MySQL. That has a whole bunch of other things there. Drizzle is not exactly a drop-in replacement for MySQL. There are some things we do not do, and we don't do those usually for very good reasons. Like we don't do views because the implementation meant that basically you could not use it once you got to a certain scale. We do not do stored procedures because pushing more code into the database server, which is the hard layer to scale, is obviously the right idea. So we try and prevent users from shooting self in the foot. And we didn't like some of the implementation there. So it is possible that you will have to adapt your app to run on top of Drizzle. That being said, the DML stuff, and to the majority of the extent DDL, is pretty much mostly compatible unless you're using these things. We have a migration tool that can connect to a MySQL server and just split the data into Drizzle and try and munge it and help you get over all the invalid data you have in your rows. And as Percona will support everything. And Skywell as well. But yeah.
How does the catalog affect the MySQL binary wire protocol? Are you going to be, is that transparent, or is it just simply going to be backward compatible?
So how does the catalog work affect the MySQL binary protocol? So I currently, because Drizzle is very modular, it could affect it however the hell we want. And my initial implementation was very simplistic because it was very easy to do, which was basically say catalog _ schema. And I don't think that will stick because it's a bit silly. I'm more thinking of the way that I see people deploying it is I would guess I want to do something where you bind to specific Ethernet interfaces and they are specific catalogs. And so then if you're doing in like a cloud shared hosting environment, you just say this is the IP address of your database server, and then you could move that to another machine or a bigger VM or whatever as a cloud provider, and it be almost completely transparent to the end user. And I'm thinking that's probably the way that people will end up deploying it. But I mean, the big thing for me was to get all the base working, and then it's like, okay, so now this is a management. I need to go and talk to a bunch of DBAs and sysadmins to work out the best way. And that was one thing that we like about Drizzle. We try and talk to people to find out a sensible way to do it. And we've gone back on some of our decisions sometimes of like, oh wait, that's really dumb if you actually want to deploy it. So we try and listen to what's most sensible for users.
Could F-Sync be any better? Does it vary from one file system to another?
So the joke sort of internally amongst anyone at Percona that does performance-related consulting is how to make your database server run faster. Step 1, use XFS. But I don't. Step 2, use XFS. Step 3, what are you still doing using something else? I mean, so there is a lot of reasons why XFS is the best for that. And a lot of them come down to implementation-specific things around mutexes and direct I/O. And pretty much every benchmark that anyone has ever run that has had the right options turned on to make things durable, remember, turn off durability and you get way faster. XFS with database servers always outperforms everything else, and it's also fairly reliable. Yeah.
Here's a hint. XFS runs on systems with 512 cores, all of which are doing I/O. What do you think its concurrency strategy is like?
That can pull at least, was it 9.7 gigabytes of I/O through file system I/O out of a 10 gigabyte per second I/O subsystem? Yeah. It was doing that 5 years ago, right? That's just like old hat. And the scaling stuff there is all in it. And so some people run it on other things and deal with it, but like using XFS and like a few tuning parameters on InnoDB is the big way to scale things up and better. Yeah. Same applies for Drizzle. It's the same storage tech. There are cookies up here. I'm just going to not be bothered running. So, it's you all run down and trip over and get injured.
So with the catalog feature, you mentioned that you do group commits across all catalogs on the same server. Do you have some sort of isolation model for IOPS between different catalogs?
So we don't currently have isolation models between IOPS between different catalogs. The holy grail there is to have at the end where you have group commit working so well that you basically have X number of like fsyncs you can do on the machine, and you just always do that, and whatever is ready to commit you throw into that and kind of hope for the best. And at some point you're going to have problems with managing things and rate limiting things, and we don't have the big sort of rate limiting things going on everywhere. I mean, there are some tools there like how many maximum connections someone can have and all that kind of stuff, which we now have to do a bit of a rework to make all of those per catalog. So suspect over the next, however long it is, a bunch of those sort of configuration variables could end up also being per catalog. And I think a lot of that stuff can also be driven by, user demand, for example. So like doing non-equal sort of resource allocation for catalogs will be something driven by, who wants it, who wants to go and implement it, who wants to pay someone else to implement it, that kind of thing will definitely be a model. But, we're definitely about, hitting the problems on the hammer as they come up. But that was the hard bit. Cool. So questions?
What are the benefits of the shoes with the toes?
Oh, it's about shoes. 5 fingers are awesome.
For the catalog stuff, what happens with global variables? So, if I connect to one of the catalogs and I set fsync off or change my InnoDB size, how is that handled?
So there'll be some options that are going to just have to be global, like InnoDB log size. That's going to have to be global because you're going to run one instance of InnoDB. I mean, you could run. In the ideal world, InnoDB would be a piece of software you could run multiple instances of in the one process. Yeah. So otherwise, you're going to have some things that are going to have to be global, and I think we're going to have to come off with sort of other resource allocation strategies that will be sort of per catalog or across for each catalog. And I mean, some of these are not completely solved. Like for example, do 2 different catalog users want to use different authentication schemes? How do we deal with that? I mean, if it's table-based authentication, that's really easy, right? Because they just resolve it based to the catalog that you're connected to. But for things like some global variables, it's going to be we have to make a decision here. And so part of that is still, we should work out the best way to do it. Cool. Oh, Andrew, do you have a...
Well, I was just going to comment that based on that, I mean, it's a nice theory, but no one's going to be able to deploy it because, I mean, for all the loss we get with virtualization, I mean, there is good isolation there, right? And so, I mean, no security auditor is going to pass off if there's the ability of one partition to interfere with another. I mean, you're not going to be able to paper over this.
Yeah, so I mean...
Nobody's going to be able to sell this. I mean, it'll sound good, but you're going to have to hit this one straight on.
Yeah, I mean, we're definitely going to have to look at things like CPU usage limitation. I mean, already you cannot do cross-catalog queries, which is the main thing of like, you cannot get at somebody else's data is the big blocker. And I mean, currently with any shared, so going straight from a shared hosting environment to this, you already get the huge benefit of it is impossible to query another catalog's data. You have to connect to the catalog you want to query. So it's a big benefit over that. If you're looking at a system, so the next level up from that of you don't want CPU interference there, then we sort of need to add in a few more restrictions than are currently there. And that's mostly feasible, right? And you then sort of eat the fact that you're going to have still a couple of CPUs on the machine. They're going to service every catalog. And people are also going to want to be able to do user accounting on these things to be able to charge for them, right? So instead of charging like, X amount for X amount of gigabytes, charge, per query or per, IOP or some kind of charging model that isn't just, X many gigabytes on disk and and the like. So I think we're definitely going to have that at some stage to be able to do the accounting, and then that can come into things for limiting. And so there's already been a number of implementations on top of MySQL to help work that out when you have sort of large-scale environments that do this inside companies, where you have now they want user stats and user limits, and to be able to, like, you know, just hit individual accounts on the head saying your app now sucks, we're going to block you from interfering with everyone else. So we'll have, you know, there'll be stuff like that is around, or indeed, you know, already is once you write some scripts to limit it and kick things, but we definitely want more things to limit and be able to partition off resources a bit better. And I mean, you know, you can do this with the big hammer, which is like, okay, VMs and pin them to certain amounts of CPU and the like, but this has the benefit of that people can sort of, you know, overuse and grow and shrink capacity sort of as needed, so it's a bit more variable, and you get the benefit of, you know, less IOPS going to disk. So it will be one of those compromise things. At the end, there are some apps where you're just always going to have to run your own hardware or inside your own VM or something like that. I mean, you know, credit card data being the ultimate example of, like, you know, but then again, that could be a small subset of your data set, in which case you pay everything to do that properly, and there are other bits that may be okay. So, I mean, in this case, I think it's still going to be a hybrid approach, and it's not, you know, the solution to everything, but it's the solution to a bunch of things, I think.
So let me have a slightly alternate answer to that. One of the uses of catalog is so that the OpenStack people can implement RDS. This catalog may not be useful for you if you have a whole bunch of security requirements on you, or you're an ordinary data center, an ordinary application. But if you're spinning up a gigantic OpenStack or giant data center, you want to a service provider where you want to give access to other people, then the catalog is for you.
Yeah, database as a service is definitely something that this plays into pretty well for more efficient use of hardware.
Okay, folks, I think we'll close it off there. And Stuart, thank you very much for a very interesting talk.
Thank you. There's a couple more cookies.
The Linux conference has got a little gift for you as a memento.
Thank you.
Small penguin.
Thank you.
Thanks.
Do come up, ask me more questions. I'm also here and happy to talk things. Yeah, excellent. And if anyone wants a chocolate biscuit. Oh, you can have a chocolate biscuit.
With free beer. Have a look at the box.